Around 300,000 people per year are going to be diagnosed with breast cancer, and about 45,000 of the current population of people diagnosed with breast cancer will eventually die from the disease each year. So since cancer is such an aggressive disease, it's really important to catch it as early as possible. And my research focuses on diagnostic imaging, specifically imaging of cancer using X-ray machines. There's quite a few limitations with current technology. First is that it's quite invasive. The woman's breast is going to be compressed and clamped, which is going to be painful. It might also be culturally insensitive depending on your background or demographic. And second, traditional mammography uses an X-ray system. And the way X-rays work is that different types of tissues are going to absorb X-rays differently. And in the cases of high-density breasts, the tumors are actually going to show up the same as the fibrous tissue on conventional mammography technology. And for that reason, it becomes really difficult for the radiologist or physician to accurately diagnose. So there exists this really exciting avenue that we're pursuing in my lab that focuses on a novel way to characterize different tissues within the body. We can use X-ray diffraction imaging, which allows material characterization based on the tissue structure and chemical properties, incorporated with machine learning to classify different tissues for the radiologist as benign cancer, metastatic cancer, fatty tissue, or fibrous tissue in the breast. The computer is going to be trained with what we call a learning data set. The data set is fed with multiple images of pathology slices, and one by one, the computer is going to learn how the signal and spectra that come out of those slices mean different things. So the machine learning algorithm is going to know that so well that it will be able to efficiently classify each signal that it gets from the pathology slice into one of those categories. This reduces the amount of false positive or false negative results. It also allows us to often catch the disease earlier, as we can classify even small amounts of the tumor. Gaining exposure to machine learning has really humbled the sense of what I understand and what I think I know. It requires, I think, more diverse avenues of thought like machine learning or computer science or mathematics to try to understand problems from different perspectives. And by looking at problems from a multitude of different perspectives really allows me to not only understand the problem, but think of unique solutions that I wouldn't have thought of otherwise. In the ideal future, in 20 or 30 years, I'd expect mammography to be completely revolutionized. It's going to be significantly less invasive. There won't be need for compression of breast, which causes, cultural insensitivities or pain to the patient. There won't be need for invasive biopsies that occur if there are inconclusive results. And hopefully all of that work combined will reduce the number of people dying from metastatic breast cancer.